In this video, we will be discussing Experiment 8, SN1 and SN2 reactions. The first part of the experiment we will be starting with is SN2, the synthesis of 1-bromobutane. SN2, as a reminder, just stands for substitution nucleophilic bimolecular. And then we're also starting with SN2 just because the reflux will take an hour while you can begin SN1 as it is refluxing. So to begin, you're going to take 1 butanol, a test tube with some boiling stones, and sodium bromide, and add it along with some water and some sulfuric acid. And then again, you will reflux for 1 hour. So the steps of this mechanism began with the protonation of the alcohol using the sulfuric acid, the nucleophilic attack of the carbon, so that bromine coming in and attacking, and then the displacement of the water. And then the last thing happens is the backside attack of the nucleophile on the primary alcohol. So at the end, we will have 1-bromobutane and alcohol as a byproduct. Now, it is important to note that this mechanism is less ideal on secondary and tertiary substrates. So while you're performing this experiment, just make sure to handle this sulfuric acid with care, and also just cool the reflux to room temperature before you begin the workup. So the workup involves, after reflux, you are going to add about 5 milliliters of water, and you will see your product separate to the product we want, the 1-bromobutane, and then the acid and the water on the bottom. So you're going to pipe out the top layer, so it's just your product, and then you're going to begin the workup of more DI water, saturated sodium bicarbonate, and saturated sodium chloride, and then you're finally going to dry it over anhydrous calcium chloride or sodium sulfate. So in this experiment, the analysis we're going to be doing of our 1-bromobutane is, of course, getting the mass of our product, the gas chromatography to clarify the purity, and then a sodium iodide test to check the overall success of your experiment. So the sodium iodide test involves taking 15% sodium iodide, adding it to a test tube along with 5 drops of the 1-bromobutane, and then after a while, probably at room temperature, you probably won't heat it, you should see a precipitate form, and you will record your observations. So in the bin for this experiment, you will have a 10 milliliter graduated cylinder, an 125 milliliter Erlenmeyer flask, a 125 milliliter separatory funnel, as well as the stopper. You will have a 250 milliliter beaker and 2 50 milliliter Erlenmeyer flasks, a 50 milliliter graduated cylinder, a amber bulb, and a micro spatula. You will also have the magnetic stir bar and its retriever, and then you will have a test tube and the test tube rack.
Okay.
Well, apparently you actually have 6 test tubes? Yeah. And then 3 of these little vials with caps for the GC.
Yeah, so almost 23 glasswares. So let's start now. So for SN1, SN2 reaction, here you can see these are all chemicals which you will find in the fume hood. Be careful once you work here. This is the hydrochloric acid concentrated, and this is sulfuric acid. So work very careful. Do not spill anything, or do not spill on your clothes. So always use gloves, goggles, and lab coats, and toe cover shoes, so that you will be protected. And this tertiary butanol usually remain at solid at room temperature. That is why we kept it in the 50 degrees Celsius, so that we can weigh easily. So okay, let's start the reaction now. Okay, so for SN2 reaction, we have all these our material here. These are the boiling stones, and then this is the 2.033 gram sodium bromide. Here I have already measured 1 ml water, DI water, and then this is 2 ml 1 butanol, and now here we have sulfuric acid. So be careful with the sulfuric acid, which is 1.5 ml. And now it's time to add. So for the addition, I'm going to add 2 boiling chip first in this vial, then add this sodium bromide, next we have to add water. You can add from the side, and then after water addition we can move with this to settle down, and then here we have 2 butanol, so we can add 2 butanol as well from the side. Here you can see, so that all the sodium bromide can go inside. And next we will put our reaction vial into ice bath like this one, and let it cool down for 2 minutes, and then I will add the sulfuric acid drop wise. So we'll wait for a moment. Here you can see it's nice white mixture, reaction mixture. Next thing, after cooling for a few minutes, we will add drop wise. So here add very gently, very carefully sulfuric acid into your reaction mixture drop wise. And as you will add, here you can see this color change, so you can just gently mix it like this, and then keep it in the ice so that it will be remain at cold, otherwise this is exothermic reaction. Here you can see it start fuming. So this addition is complete, and now it's time to change the ice and keep it in the, we can mix with and as you will mix, here you can see it changes more color, so which is nice. So what I will do, I will stand my reaction mixture here for a moment. Be careful like this, and then throw all the ice, add some water to make it water bath for heating, and now I will going to add my reaction mixture into water bath. So this will be my water bath for heating. So this will keep it on the hot plate, and you can mix with this spatula one more time probably, so that all the reaction mixture can mix together. And now it's time to set up on the heating plate. So start your heating plate. Probably I will set up 200 degree first, and we'll see after some time how far it is going. Basically this is the water bath for heating. So we need almost 100 degrees Celsius. So we'll come back after some time to see how my reaction is heating. So here you can see within after 2-3 minutes the plate reading is around 200 degrees Celsius, but my reaction is still not heating. So I'm going to increase the temperature to probably up to 300, because outside temperature is different than inside bath. And so I just label it here near that this is my SN2 reaction which we are doing in the test tube. And also make sure that you secure your reaction while through clamp. So just use this clamp. I like to show you like this one, how from the side you can see. And now water start warming up, very hot. It's around 301, and we'll come back after some time to see how temperature is increasing. So now total 12 minutes so far. Here you can see water start bubbling. It's still not started boiling, so probably we are around 80 or 70 degrees Celsius. So I'm going to increase the temperature once again around 350, and then we'll see after some time. And we can do one thing, that you can just stir using a rubber this pipette, glass pipette. Gently, just do not do anything. So optimum temperature for the hot plate is around 330 to 340 degrees Celsius. Here you can see around 333, and very nice reflux is occurring, reaction is refluxing. Okay, so here this reaction is almost 1 hour reflux. So after refluxing, we have to switch off this heating here and use these hot mist to remove. It's very hot right now, and you can use 2 of them like this, and then let it cool down for room temperature before workup. And we can also remove the hot water from here. Be careful, it's very hot. And then let it cool down. Once it will cool down, here we will start workup. So here very nice, you can see there are 2 layers. Aqueous layer at the bottom, your product will be on the top. Then we will start workup.